Good morning, everyone. Good morning, everyone. Are we live? Please tell me in the chat section. Are you able to hear me? Good morning, everyone. Good morning. Are you all able to hear me? Just tell me in the chat section. Good morning. Hello, Ritu. Good morning. How are you? How are you all? Yes. All right. All right. So we'll wait for a couple of minutes, then we'll start our lecture. Today is very important lecture. Hello Aarthi. I am also good. I am also good. How are you all? Great. Today is very important lecture. Today we are going to study about resonance. Today we are going to study about resonance. All right. So I again welcome you all to India's largest education platform, Unacademy. This is Let's Crack NEET UG English platform. All right. So hello everyone, I'm Nitesh. My name is Nitesh Devnani and I have 5 years of teaching experience in chemistry, and I have taught over 2000 plus students and who have scored great marks in NEET examination. Ritu, we will do inductive effect surely, but first we are learning about resonance. The next class we will do about inductive effect. All right. Alright, so let me tell you about the subscription plan first of Unacademy. What would be the benefits if you would be getting if you subscribe to this plan? First of all, you need to download this Unacademy learning app. It is a this app would be very beneficial for you. There would be a free classes also, and just download this app after this session. All right. Good morning, Jayesh. Good morning. Alright, so once you subscribe to the Unacademy Plus program, you'll have daily live classes, you'll have live tests and quizzes, you'll have structured courses, as well as there would be unlimited access. You would get unlimited access, alright, by Unacademy subscription plan. Alright, see, as I've told you, there are free live classes also, but these classes are on Unacademy learning app. So you need to download this app to access all the free live classes. All right. Alright, so these are the top educators: Dr. S.K. Singh, Pranav Pundarik, Anmol Sharma, and Dr. Anand Manisar. Alright, now if you buy the subscription plan, let me tell you about the pricing. Whenever you buy the subscription plan, you need to enter this code Nitesh YT. By this code you will get 10% off. 10% off. Alright, and your 12-month course would be reduced. Your 12-month course would be reduced to 27,000, and 24-month would be reduced to 34,400 rupees. All right, so you just need to buy whenever you buy the subscription plan, just apply this code Nitesh YT. All right. Let us now start our class, and we will Ritu, we will surely cover geometrical isomerism. All right, we will conduct a special class on the platform, and we will surely conduct each and every topic. Inductive effect would also be covered after this video. All right, so now let us start our class. This is resonance video. All right, this is a one shot video. In this complete video you will be taught resonance, and this will be a bit long video. All right, because we need to cover resonance in very depth. All right, so you need to understand it very carefully, and please watch the complete class. All right. So are you guys all ready? Jayesh, Aarti, Ritu, are you all ready? Let us start the class. for resonance. All right, this will be a long class, so you need to attend the complete class in order to understand resonance completely. All right, so let us start our lecture. We are going to study today about resonance. All right, about resonance. Just look at here. Just please pay. Concentrate here. Acha, give me a thumbs up in the. At least give me a thumbs up in the chat section that yes, we are. You guys are ready to study resonance. Just give me a thumbs up so that I should know. All right. Let us study. Let us study about resonance. All right. All right. See how resonance was discovered. First, I'm going to tell you about how resonance was discovered. This is benzene structure. This is benzene structure, correct? This structure is benzene structure, right? So see, the structure of benzene can be like I can shift the pi bonds also. Like here there is one pi bond. I can shift this pi bond here also. Like the structure can be like this also, correct? Both the structures are what? Equivalent, correct? Both the structures are equivalent. So these type of structures, like these type of interconvertible structures, are known as resonating structures. These are known as resonating structures. These are known as resonating structures. This is rs1, this is rs2. All right, similarly, let me give you one more example of resonance. See, formate ion. This is your formate ion. All right, now tell me that this negative charge can be on this oxygen also, na? Like the structure could have been like this also. The structure could have been like this also, na? Both are what? Both oxygen are equivalent, both are same structures. So again, these two structures are what? Interconvertible. All right, this is resonating structure 1, this is resonating structure 2. If you carefully observe these two examples, only we are shifting pi bonds and lone pair electrons. See, here we have shifted pi bond. Because pi bond is loosely bound, we can easily shift it. Pi bond is weaker. All right, so pi bond we are shifting. Here also this negative charge means lone pair. We are shifting lone pair and this pi bond, correct? Got it? So in resonance, we are interconverting pi bond and lone pair. All right, so these are what? Resonating structures. Are you getting my point? These are resonating structures. All right, now see, just look here. We need to write a resonance hybrid. See, resonating structures are hypothetical structures. These two structures are hypothetical structures. All right, what is real structure? Real structure is resonance hybrid. Now please see carefully, how do we write resonance hybrid? All right, just first write down all the sigma bonds. H, C, oxygen, all the sigma bonds. Now just pay attention here. Just look at here. See, in the resonating structure 1, there is pi bond here, and in the resonating structure 2, there is pi bond here. So basically pi bond is shifting its position between these two oxygen, correct? So there is, like, we represented with this dotted line. This dotted line means partial bond. Why? Because that particular pi bond is now shifted to these two oxygen atoms, is continuously shifting. So we write it as partial bond. Are you getting my point? Just give me a thumbs up in the chat section if you are able to understand this. And if you again carefully observe, see, this oxygen has negative charge here, this oxygen has negative charge here. So again the oxygen atom is also being, negative charge is also being distributed among both the oxygen atom, correct? Among both the oxygen atom, negative charge is distributed, right? So we write it as del negative. Del means not 1, less than 1. So the negative charge is distributed on both the um, oxygen atoms. Are you able to understand this? This is known as resonance hybrid. This is known as resonance hybrid. This is your real structure. Resonating structures do not exist in real. Resonating structures do not exist in resonating structures do not exist in real life. They are hypothetical structures, and resonance hybrid is the actual structure. All right. All right. Are you able to understand this? Just give me a thumbs up in the chat section. Just give me a thumbs up in the chat section if you are able to understand this. Alright, so this was a basic understanding. We have to study a lot about resonance today. A lot of examples we are going to study. Great Ritu, Aarti, great Jayesh, Rajni, Kavya. Kavya, reaction mechanism. I have told you about electrophiles and what is the basic mechanism of the reaction. Like what is the substrate, how attacking reagents attack on the substrate. And in further classes, we are going to talk about intermediates. We are going to talk about inductive and hyperconjugation. Everything is in order. We are studying complete course in order. Alright, you just need to attend regular classes. You will come in regular classes, you will achieve your target. All right. So let us start further. Let us go further in resonance. We have covered this is basically basics of resonance. Now we first need to write down conditions. What are the conditions for resonance? What are the conditions for resonance? All right. We first need to write down conditions of resonance. So please pay attention here. Please pay attention here. First condition is atoms participating in resonance must be planar. Planar means they have to be in one plane. Your molecule, the atoms, those are participating in resonance must be in one plane. What do you mean by planar? All right, planar means your hybridization can be sp2 and your hybridization can be sp. If your hybridization is sp3 means the structure is non-planar. Non-planar means resonance cannot take place. All right, now see. This is C double bond C. Alright, this is sp2 hybridization. This is C triple bond C. This is sp hybridization. Are you getting my point? Alright, the structure should be planar. So if you have sp3 hybridization, there would be no resonance. Got it? Are you able to understand this? Atoms participating in resonance must be planar. Alright, second point. Position of atoms is fixed. Position of atoms is fixed. All right, let me show you this with an example. Just look at here. Hydrogen, carbon, oxygen, this oxygen, again this hydrogen, carbon, oxygen, this oxygen. See, just you look at the position of atom, they are all same. We are not changing the position of atoms. The position of atom is same. We are just changing the position of pi bond and lone pairs. Are you able to understand this? See, here it is pi bond, here you don't have a pi bond, here there are lone pairs, there are no lone pairs. So we are just interchanging the position of pi bond and lone pairs. Atom's position is remains fixed. All right, so position of atom is fixed. Third point is pi bond and lone pair. Pi bond and lone pair are interconvertible. Pi bond and lone pair are interconvertible. Their position are exchange. We can exchange the position of pi bond and lone pair. They are what? Interconvertible. Got it? And as I have told you, resonating structures resonating structures are hypothetical, right? They are hypothetical, they do not exist in real life. uh, Tell me which structure exists in real life. Come on, write down in the chat section which structure exists in real life. Resonating structures are hypothetical. Which structure exists in real? Resonance hybrid exist in real. All right, resonating structures are hypothetical, but resonance hybrid is real. All right, great. Hello Ravi. Hello. Yes. All right, are you able to understand this? So these are basic 4 conditions of resonance. If these conditions are being fulfilled, then only we say resonance. All right, now see, now see, now I am going to tell you about systems. I am going to tell you about certain conditions which needs to be followed in order to have resonance. All right, so you need to first identify, always you need to first identify if it is of particular system, then only we can have resonance. Let me give you examples of it. I am heading is types of system in which resonance is possible. Types of system in which resonance is possible. All right, okay. The first type of system is double bond, single bond. This, now you must be confused, what is this? All right, see, this is double bond. This is double bond. This is single bond. All right, and this is empty orbital. This is empty orbital. Now let me explain you each and everything. All right, first of all, the system means the sequence should be like this. First there should be double bond, then there should be single bond, and then there should be empty orbital. Now just please pay attention here. Suppose it is CH3 plus. Suppose this is CH3 plus, means carbon is forming 3 bonds with hydrogen and there is a positive charge, correct? Now if we see the electronic configuration of carbon, it has 2s and 2p, correct? 2s has 1 orbital, 2p has 3 orbitals. Got it? So these three orbitals are used for bonding. They are used for bonding. Why? Because 3 bonds are being formed. All right, now this orbital is empty. All right, so if a carbon has positive charge, it means it has empty orbital. There is no electron in that particular orbital. Are you able to understand what is the meaning of empty orbital? Give me a thumbs up in the chat section. Come on everyone, let's be active on the chat section. Give me a thumbs up. Great, Aati. Yes, everyone, please be active on the chat section. Okay, now let me tell you what does this system looks like. Yes Ritu, you will be very much able to clear with this example. Just look at this example. CH2 double bond CH2 plus. All right, now we have to see if resonance is possible in this type of system or not. All right, see, this is double bond, correct? This is single bond. All right, okay. See, carbon in this carbon has what? Positive charge. Now see, if carbon is having positive charge, it means it has empty orbital. Correct? Why? Because the final shell of carbon is having 4 orbitals. All right, three are being used for bonding. So one orbital is empty. So this has empty orbital. This positive charge means it has empty orbital. So tell me, is resonance possible? Yes, because we have found our system. Double bond, single bond, empty orbital. We have found our system. So resonance is possible. Got it? Now let me draw resonating structures for you. CH2 double bond, CH, CH2 plus. Let me draw resonating structures for you. There, see, if it is single bond, this means it is sigma bond. Correct? If it is double bond, this means it has one sigma and one pi bond. Got it? So here there is double bond. So you have one sigma and one pi. So tell me in the chat section which bond is shifted in resonance. Which bond is shifted in resonance? Tell me in the chat section. Come on, everyone. Which bond is shifted in the resonance? Yes, pi bond is shifted. Pi bond is shifted. Alright. So pi bond, this is your pi bond. Alright, this pi bond is shifted to here. This pi bond is shifted here. Just see. All the atoms, now you need to draw its resonating structure. So what will happen? Your pi bond shifts here and the positive charge goes here. Let me give you a trick. Here, let me give you a trick. See, just number the atoms like 1, 2, 3. Okay? Alright. Always form double bond between 2 and 3 and bring your charge on 1. See what we have done. We have brought our charge on 1 and we have drawn double bond between 2 and 3. Got it? Are you able to understand this? These are resonating structures. This is RS1. This is RS2. Two resonating structures. Got it? Again you will say we can shift this pi bond here. Alright, but that would again result in the same structure. So only two resonating structures are possible. Clear? Now please try to write the resonance hybrid of this. Please try to write the resonance hybrid of this. How do we do this? First you write all the sigma bonds. Alright. Then you see where all pi bond is present. Just write partial double bond there. Alright. And distribute positive charge. Try to write, come on. Try to write resonance hybrid for this, for these two structures. Come on everyone. You need to practice it. Don't worry, by the end of this class you will be very much comfortable with it. Right now you might be facing some difficulties, but don't worry. Alright. See, first draw all the sigma bonds. Okay. See, first I have drawn all the sigma bonds. Great. Now see, here there is pi bond in first resonating structures. Here there is no pi bond in second resonating structure. So there must be what? Partial double bond, partial bond. Alright. Now here again there is a single bond. Now here again there is double bond. So this bond is also shifting. So here also partial bond. Alright. Now see, positive charge. On which carbon there was a positive charge? See, there was positive charge on third carbon and there was positive charge on one carbon. So positive charge is distributed on 1 and third carbon. So here del positive, here del positive. Del means less than 1. This is your resonance hybrid. This is your resonance hybrid. Are you able to understand this? Great. Yes. Very good, Ritu. Very good. Great. Tell me, give me a thumbs up in the chat section if this is clear to you. I'll give you one more example of this. I will give you one more example of this. Just remember this trick. 1, 2, 3 system. You need to write a double bond between 2 and 3 and bring your charge on 1. Bring your charge on 1. Alright? Okay. Let me give you one more example. CH2 double bond CH, CH double bond CH, CH2 positive. Now suppose this is your structure. Please try, I'll be waiting for a couple of minutes. You write all the resonating structures of this. First see if resonance is possible. First check. To check, you need to write, you need to see the system. Double bond, single bond, empty orbital is present or not. If it is present, then resonance is present. Okay, come on. Write down the resonating structures of this. This will be a long class, but very, very interesting class and very useful class for your entire organic chemistry. Yes, I'm waiting. You just, whenever you are finished writing the structures, just give me a thumbs up in the chat section. We will continue. I will draw the structures and you can check it on later. Yes, very good. Just look at the system. This is double bond. This is double bond. Alright. This is single bond. And I have told you that this positive charge means empty orbital. Alright. Just write 1, 2, 3 system. 1, 2, 3. What I have explained you? I have explained you. Just see, you are not doing anything here. So just simply draw this. CH2 double bond CH. Now what I have explained you, simply take your charge on 1 and draw pi bond between 2 and 3. So see, CH positive, CH double bond CH2. Alright, this is your one resonating structure. Alright, yes. Now again see, yes, again see, this is your double bond. Alright, this is your single bond. And this is your empty orbital. Again resonance is possible. Yes. So again just write 1, 2, 3 system. Follow the same system. 1, 2, 3. What I have explained you. Just take your charge on 1 and draw pi bond between 2 and 3. This is a simple trick. So CH2 positive, CH double bond CH, and the remaining part we are drawing as it is. Alright, got it. So there are how many resonating structures? This is your RS1, this is your RS2, this is your RS3. There are 3 RS. Alright, now try to draw hybrid of all these. Try to draw hybrid of all this. Come on. Try to draw hybrid of this compound. Yes, first draw all the sigma bonds. First draw all the sigma bonds. CH2, CH, 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 CH2. Correct? Now just highlight the pi bonds. See there is pi bond. Alright. So there would be partial double bond. Alright. Now see, in this between second and third carbon there is no pi bond, but there is pi bond in one resonating structure. So again partial double bond. Similarly here partial double bond, here partial double bond. All the double bonds are partial. Now positive charge is on carbon. See here in the on the last carbon, on the middle carbon, and on the first carbon. So it is on del positive, del positive, del positive on first, third and fifth carbon. This is your resonance hybrid. Tell me in the chat section if this is clear to you. Come on everyone. Everyone, you need to give a thumbs up in the chat section if this is clear. If you have doubt, then ask me. I will explain you again. Then I will explain you again if you have any doubt. This was only first type of system. We need to see as 3 systems in which resonance is possible. Is this much clear to you all? Ritu, great. Aarti, is it clear? Gopal, is it clear? Be happy. Rajni, Kavya, is this all clear? Dushumanta, great, great. Jayesh, fantastic. This was your first system. This was your first system. Now let me introduce you to second system. This is your second system. Second system is double bond, single bond. This and this orbital has like this. Double bond. Let me explain you. Double bond. This is single bond, and this orbital has lone pair. So the next type of system is double bond, single bond, lone pair, or double bond, single bond. Let me explain. Double bond, single bond, and this has only one electron. See, in the first case there were two electrons. The complete lone pair was present, two electron. Alright, here only one electron is present. That one electron is known as odd electron. If this type of system is present, then we say resonance is possible. Now let me explain you what do you mean by lone pair. How can you identify lone pair? Again, see, if I am writing CH3 minus, this minus means, let me explain you. Again, this structure is carbon, this hydrogen, 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 and here it is negative charge. Alright. So see, carbon has two subshells in the final shell. 2s, 2p. Here there is one orbital, here there is three orbitals. Alright. So see, three bonds are being formed. So three orbitals are consumed in bonding. Correct? Now this negative charge means this is your lone pair. Negative charge means is your lone pair. This orbital is containing your lone pair. This orbital is containing your lone pair. Alright. So we write it down like this. This is your lone pair. Alright. So if carbon would be having negative charge, this means it has lone pair. Alright. So double bond, single bond, lone pair is your next system. Let me give you example. CH2 double bond CH, CH2 negative. Is this resonance possible in this case? You need to identify system. So this is what? This is double bond. Yes. This is single bond. Correct? And I have told you a carbon containing negative charge means it has lone pair. It has lone pair. Got it? Are you able to understand this? Alright, so double bond, single bond, lone pair, yes, resonance is possible. Again, you have to apply that trick. You have to apply simply that trick. You will be very much clear. You will be very much able to draw all the resonating structures with this. See, 1, 2, 3. What was the trick? Just make pi bond between 2 and 3 and take your charge on 1. So what would be the resonating structures? CH2 minus 1 is having charge and double pi bond between 2 and 3. Got it? This is your resonating structure 1. This is your resonating structure 2. Is this much clear to you? Is this trick clear to you? This is a very easy trick, right? This is a very, very easy trick. Alright. Now just simply draw the resonance hybrid of this. Come on. Great. Yes, Santosh. Yes, Ritu. Yes, Dushumanta. Great. Yes, Aarti. Just draw the resonance hybrid. Just draw the resonance hybrid of the structure. Come on. Alright. This would be a bit long lecture, but you need to attend it complete. Alright. If then you will be very much able to clear everything. Yes. So to write the resonance hybrid, you first need to write all the sigma bonds. Correct. Now see, here there is pi bond, here there is no pi bond. This means pi bond must be shifting. So there is partial bond. Here there is no bond, here there is again pi bond. So again this partial bond. Alright, and negative charge is being distributed on 1 and 3rd carbon. Great Ritu, yes, correct. So del negative. This is your resonance hybrid. Alright, similarly see. Similarly, if you have this example, CH2 double bond CH2 dot. This dot means odd electron. This dot means odd electron. So just see, here there is double bond. Here there is single bond. And then you have your odd electron. So see, the second type of system was what? Either you can have double single lone pair or you can have double single odd electron. Got it? So this time also resonance is possible. Alright, try writing down the structure. Come on, everyone, try this. Write down the structure, resonating structure. Same trick, 1, 2, 3, same trick. Just shift your odd electron on 1 and make a pi bond between 2 and 3. CH2 dot CH double bond CH2. Correct? This is your RS1. This is your RS2. Got it? Now try to write the resonance hybrid of this. First you need to write all the sigma bonds. Come on. All the sigma bonds. CH2, CH, CH2. Correct? Now see, here there is pi bond. There is no pi bond here. So this means it must be having partial pi bond. There is single bond here. There is pi bond here. So again there is partial bond. Got it? And your odd electron is shifted on carbon 1 also and carbon 3 also. So del dot matlab means less than an electron. Alright? Yes, Richu, great. Alright, so this was about your system 2. Alright. Okay. Let me tell you one more example. Let us see one more example. Alright? Let us see one more example. CH2 double bond CHO negative. O negative. Negative charge means lone pair. Alright, try. Come on everyone, try this question. Draw resonating structures of this. You need to find the system. System is double bond, single bond, and negative charge. Wherever is it? This means it has lone pair. So yes, second type of system is possible. Yes, it is possible. Yes, Santosh, great. Same, right? Just take your charge on the 1, 2, 3 system. 1, 2, 3. Just take your charge on 1 and double bond between 2 and 3. CH2 negative, CH double bond oxygen. Alright, so this was your RS1, this was your RS2. Fantastic, great. Now try to write the resonance hybrid. Of this. First write all the sigma bonds. Okay, CH2, CH, oxygen. Correct. Now see, double bond is here, double bond is not here. So this must be having partial double bond. Double bond is, single bond is here, double bond is here. So this also has partial double bond. And a negative charge is distributed on first carbon and your oxygen. This is your resonance hybrid. Are you very much able to understand this? Tell me in the chat section. Is this much clear? Great. Yes, Santosh, Ritu, Richu. Great. Dushumanta. Fantastic. Fantastic. Great. So second type of system is clear to you. Let me now introduce you to third type of system in which resonance is possible. Double, single, double means this is your double bond. Alright. This is your single bond. And again this is your double bond. Alright. In this type of system is there is also resonance is possible. Let me give you an example of this. Alright. CH2 double bond CH, CH double bond CH, CH3. Alright. Just look at the if system, if it is possible or not. Come on. See, this is your double bond. This is your double bond. Alright. This is your single bond. Alright. And again here there is double bond. Correct? So in this type of systems, yes, resonance is again possible. Alright. Let me draw resonating structure for this. Let me draw this. CH2 double bond CH, CH double bond CH, CH3. Alright. So see, what is the resonating structure of this? Your pi bond shifts here and your this pi bond shifts here. Alright. Okay. Now let me see. Let us observe this carbon. So the electrons are moving away from it. So it would acquire positive charge. But it's electrons, if electrons are going away from it, it would acquire positive charge. So it has CH2 positive, double bond is in between these two, correct? And see, let us observe this carbon. So the electrons are coming over it. So this must be having negative charge. Alright, this was your one resonating structure. Alright, let me draw again one more resonating structure. The same thing could have been this pi bond. This pi bond would have been shifted here, and this pi bond here. This would have also been possible. Got it? So see, now let us observe this one carbon. The electrons are coming over on it. So this can have charge negative. There is pi bond between these two. And let us observe this carbon. Electrons are moving away from it. See this arrow. So CH positive, CH3. Alright. So this is your resonating structure 1. This is your resonating structure 2. This is your resonating structure 3. Got it? How many RS? 3 RS. Now try to write the resonating hybrid of this resonance hybrid. Come on everyone. Try to write the resonance hybrid of this. This was our last system. Come on everyone. Just simply write all the sigma bonds first. Then see where there is charge. Is this charge neutralized or not? Just observe it. Just observe it. See, first write all the sigma bonds. CH2, CH, 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 CH3. Correct? Got it? Now see, there is pi bond. Alright. So this must be having partial bond. Here is also pi bond. See, in between second and third. So again partial bond. I see similarly here also partial bond. No partial bond for the last one. See, because always in all the resonating structures it has a single bond only. So no partial bond, no partial double bond in the last carbon. Got it? Now please check for the charge. See, resonating structure 1 has no charge. Resonating structure 2 has positive charge on one carbon. Resonating structure 3 has negative charge on one carbon. So this is neutralized. Yes. Resonating structure 2 has 4. On 4 carbon there is negative charge, and resonating structure 3 on 4th carbon has positive charge. So again it is neutralized. Are you able to understand this? No charge would be developed on resonance hybrid because charge is being neutralized here. Got it? Come on everyone, give me a thumbs up in the chat section. Come on everyone. Is this much very clear to you all? I need to know. Come on. Richu, Santosh, Ritu. Yes. See, you just need. Are you able to understand how I have made these resonating structures? You just need to shift the pi bond, right? See, there can be two examples. See, I'm again explaining you. This pi bond can be shifted here also and can be shifted here also. Alright, similarly this pi bond can be shifted here also, can be shifted here also. So there are cases. That's why we have made these type of structures. There are cases. Now for the charge. See, tell me resonating structure 1, does it have any charge? Yes, I'm explaining it again. Resonating structure, does it have any charge? No, right? No. All right, resonating structure 2, just observe one number carbon, it has positive charge. Resonating structure 3, it has negative charge on first carbon. So positive, negative both are what? Neutralized. That's why there is no charge on first carbon. Got it? Now resonating structure 2, fourth carbon, this one, what is the charge? Negative. Resonating structure 3, fourth carbon, what is the charge? Positive. So again both are neutralized. So again see, there is no charge on fourth carbon. Alright, so charges are neutralized here. That's why there is no charge on resonating structure. Now I hope this must be clear. This was your third type of system. Double bond, single bond, double bond. Fantastic. Great. So you are very much able to now identify in what all systems resonance is possible. You can identify it now, correct? Three type of systems were there: double bond, single bond, empty orbital, double bond, single bond, lone pair, and double bond, single bond, double bond. All right, great. Now see, we have just seen that there can be multiple resonating structures of of any atom, of any molecule, right? There can be 2 structures, there can be 3 structures, similarly there can be 4, 5, 6, etc. I'll show you all right, in just in today's class only. All right, so see, all the resonating structures, I'm writing a note here, all resonating structures have different stabilities. Every resonating structure have different stabilities. You can compare resonating structures stability. All right. Yes, Richu, we will be completing. We will be completing complete GOC. Yes, already the lectures are being uploaded. I think this is your third or fourth lecture, I think so. So you can watch those lectures and ask me doubts. All right. See, so all resonating structures have different stabilities. All right. So you can really compare all the resonating structures. Their stabilities, you can compare them. Now resonance hybrid. Resonance hybrid is the actual structure. I have told you before only. Resonance hybrid is the actual structure. So resonance hybrid is most stable among all. Resonating hybrid is the most stable among all. That's why resonance hybrid is the real structure, because it is what? Most stable. All the molecules in this world wants to attain stability. So resonance hybrid is the most stable among all. All right, is this much clear to you? Now let me give you rules to find stability of resonating structure. Now let me give you rules, some rules. Alright, there are some rules. Tell me in the chat section if this much, whatever we have taught, this much clear to you. Tell me in the chat section, come on. Tell me in the chat section if this is clear to all of you. Give me a thumbs up. I'm going to write down rules now. All clear. Great, Ritu. What about Richu, Santosh, Jayesh, Arthi, Dushumanta? Is everything clear? Shabika? Fantastic. Alright. So let me give you some rules to find the stability of resonating structures. Alright. So the first rule is, and all these rules are on priority basis, means the first rule has the highest priority. So you always need to check first rule, then second rule, then third rule. Alright. First rule is, more the number of pi bond, more the number of pi bond, more is the stability. More the number of pi bond, more is the stability. Let me give you examples. I will give all the examples. Yes. See, suppose CH3 C double bond OOH. This is your structure. All right. So first tell me, is resonance possible? Come on, everyone. Is resonance possible? You need to identify that type of systems. You need to identify all those systems. See, this is your double bond. This is your double bond. This is your single bond. Correct? Now, oxygen atom is making two bonds, one with the carbon, one with the hydrogen. Oxygen atoms have 6 electrons in their valence shell, and 2 are used for bonding. So it must be having these 2 lone pairs. So yes, resonance is possible. You need to identify. We will be taking more examples. Yes, Richu, we will be taking a lot of examples. Alright, so see, double bond, single bond, lone pair. So yes, resonance is possible. Is this much clear? Alright, so see, if I write a resonating structure of this, see, CH3C. Now this pi bond I am breaking into positive and negative charge. I am breaking into positive and negative charge. This is your resonating structure. So now this is your A, this is your B. Tell me which is more stable. Come on, everyone. A or B? More the number of pi bond, more is the stability. Which compound is more stable? A or B? A is more stable than B. Why? Because A has 1 pi bond. B has no pi bonds. B has no pi bond. So A is more stable than B. So first you need to see the number of pi bonds. Alright. If this is clear to you, just hit the like button if you are all very much clear with it. Very good, Ritu, Santosh, Richu, great. Alright, let us move on to the second rule. Let us see second rule. Neutral structures are more stable than charged structures. Alright, let me give again an example of this. CH3 C double bond O OH. Now tell me, resonance is possible? What type of system is this? Write in the chat section what type of system is this. To check resonance, you need to check the system. Yes. What type of system is this? Yes, same. This is your double bond. This is your single bond. And this has lone pair. Correct? Alright. Okay. Now what I have explained you? Now I have explained you lone pair means negative charge. Lone pair means negative charge. I have explained you 1, 2, 3 system. Correct? That trick I have shown you now. 1, 2, 3 system. So see, 1, 2, 3. You just need to make a double bond between 1 and 2. Sorry, double bond between 2 and 3. And negative charge on your one atom. So see what happens. Now let me clear this to you. This lone pair is traveling here and this pi bond is traveling here. Alright. So see, if we observe this oxygen, it is donating electron. So it must be having what? Positive charge. Now let me observe this oxygen. So it is gaining electrons. Alright, so it has negative charge. Alright, so this is your A, this is your B. What was the first rule? You first need to, these all rules are on priority basis. What was the first rule? First check the pi bonds. Come on, first check pi bonds in both the structures. Come on everyone, check. Come on everyone, check number of pi bonds. Check number of pi bonds. Yes, both have a 1 pi bond. First you need to check number of pi bond. This also has 1 pi bond. A also has 1 pi bond. B also has 1 pi bond. So by rule 1 we are not able to differentiate. Then what is the second rule? Neutral structures are more stable than charged structures. So A is neutral, B is charged. So it has negative and positive charge. See now if you will say this, that overall it is neutral because one is positive, one is negative. We are not talking about overall charge. We are just talking about if there are charges present or not. Alright, so A is more stable than B. Both have 1 pi bond. So we are not able to differentiate on the basis of 1. See, pi bond means this, if it is single bond, this means it has sigma bond. Alright, pi bond is your second bond. This means it has 1 sigma and 1 pi bond. Got it? So both have 1 pi bond. Alright, both have 1 pi bond. Now second rule was neutral structures are more stable than charged structures. Alright, let me now give you third example. Please tell me, is this much clear to you? Rule 1 and rule 2 are clear to you? Shall I move on to the third rule? Please tell me in the chat section. Yes. Okay, Ritu. Okay, Ritu. Great. Yes. So third rule is opposite charges close are more stable. Wait, I'll explain you. Right? Let me write. Opposite charges close are more stable. Same charges close are unstable. Like we say opposite charges are what? They attract each other. Alright. Yes, Munzir. Yes, Santosh. Fantastic. See, opposite charges attract each other. That's why if opposite charges are close to each other, they are more stable. And same charges repel. So if they are close, they are unstable. Okay, let me give you example. Of it. Now see, this is your benzene, and suppose on benzene you have your OH. This has this lone pairs. Now first tell me in the chat section, is resonance possible? Whenever I am asking this, is resonance possible, you need to check the type of systems possible. See, I need to find resonance with this oxygen. You can obviously say the benzene ring. The benzene ring has resonance, double bond, single bond, double bond, single bond, double bond, single bond. Tell me if resonance possible with oxygen atom. What type of system is this? What type of system is this? See, again I'm explaining you. This is what? Double bond. This is what? Single bond. And this is what? Lone pair. So yes, this is possible. This is possible. Now how do we do it? Your lone pairs are transferred here. Your pi bond is transferred on this carbon. So please see. See. Now see, you haven't disturbed this pi bonds. So just make these pi bond as it is. See, oxygen is donating its electron. Oxygen is donating its electron. So there is double bond between this oxygen and this carbon, and oxygen must be having positive charge because it is donating its electron. Now this pi bond is shifted on this carbon, so it has negative charge. This is possible. Now again tell me, in the benzene ring with this negative charge, resonance is possible or not? Come on everyone, tell me in the chat section. If it is possible, tell me type of system. This negative charge means it has lone pairs. It has lone pairs. See, again this is double bond. Correct. This is single bond. And this is lone pair. Got it? So again there is resonance. So what do? We pass on to the lone pairs here. We bring pi bond here. Alright, same 1, 2, 3 system. You can follow 1, 2, 3 system here also. 1, 2, 3. We are making, see, 1, 2, 3 system. See, which you haven't touched this. You haven't touched this. We are making as it is. Alright. Now simply make a double bond between 2 and 3 and bring your charge on 1. Alright. Double bond between 2 and 3 and bring your charge on 1. Alright. Now this is your A. This is your B. This is your C. Come on. Apply all the rules. All the 3 rules apply and tell me the stability order of A, B and C. Come on. Come on everyone. I've told you this would be a bit long class, but this is a very, very special class. Alright. Fantastic. Great. Come on. Tell me the stability order. Just give me stability order. Which is most stable and which is least stable. You first need to check number of pi bonds. Come on, check number of pi bond. First check number of pi bond. Hello Devaki. See, this has 3 pi bond. In the benzene ring you have pi bond, na? So you have 3 pi bond. Alright. See, B structure also have 3 pi bond. 1, 2, 3. 3 pi bond. Your third structure also has 3 pi bond. 1, 2 and 3. Here also 3 pi bond. Fantastic. All have same pi bond. So first rule is not applicable. You cannot differentiate on the basis of first rule. What was the second rule? Let me show you. Second rule was neutral structures are more stable than charged structures. Alright. Come on. Now tell me the order. Pi bonds are same in all the 3. Neutral is A is neutral and B and C are charged. There are charges present. See, there is charge on oxygen. There are charges on carbon. So A is more stable than B and C. Alright. A is the most stable because it is what? Neutral. Got it? Now tell me difference between B and C. Who is more stable? Which is more stable? I have told you that opposite charges must be close. So this is what? This oxygen has positive, this carbon has negative. This oxygen has positive, this carbon has negative. So if the opposite charges are close, they are more stable. If the opposite charges are far, they are less stable. So yes, in B, the opposite charges are close. So then B, then C. Very good. Very good, Richu, Devaki, Ritu. Fantastic. Santosh. Is this much clear to you all? All the rules are on priority basis. You first check one rule. If you are able to solve your question with the first rule, well and good. Then move to the second rule, then move to the third rule, and slowly and gradually you need to apply all these rules. All right, is this much clear to you? Just give me a thumbs up in the chat section if this is clear to you. Just give me a thumbs up. Just give me a thumbs up in the chat section, my dear lovely students. Hello Govindam. Hi, hello Govindan. Great Kajal. Great Richu. Great Ritu. Devaki, Govindan. Fantastic, fantastic. Great, great. Alright, alright. Now we are moving on to the very important topic. Very important topic. Types of resonance. Types of resonance. Alright, alright. Types of resonance. First, tell me in the chat section. Come on, before completing this, tell me in the chat section, are you able, is this class very interesting? Tell me in the chat section, is this class very interesting? And I hope you are not bored. You are not bored, right? This is very interesting class. Tell me in the chat section. Yes, Richu, will do. Great. Yes, Ritu. Devaki, fantastic. Everyone, please be active on the chat section. Yes. Great, great, great. Now you will find this types of resonance even more interesting. Just focus here. There are two types of resonance. There are two types of resonance. Two types of resonance. Please be very careful. Please listen to this completely. Ritu, I have told you I will be doing stereoisomerism also, and we would be having our next class on inductive and hyperconjugation. We are not skipping any lecture. We are completing whole syllabus in a sequence manner. Alright, I know when I completely understand this feeling of yours, and I know what I have to teach you on what time. Alright, so don't worry about it. I will be teaching you complete chemistry. Great, Devaki, thank you. Great, great. There are two types of resonance. See, first is there is plus R. First there is plus R. Plus R we can write it down as electron donating groups. Electron donating groups. Alright? Alright. So let me give you an example of this. This OH group is attached to benzene. This oxygen has lone pair. Alright. Now we would, in the previous example only, we have drawn resonating structures. Let me draw again resonating structures of all these. See, resonance is possible. What is the system? Double bond, single bond, lone pair. Your lone pair are shifted here. Your pi bond is shifted here. Correct? So what is the structure? Let me draw the structure. See, first make those things which you are not touching. See, these all pi bonds I have made. Alright. Now see, there would be a double bond between this oxygen and carbon. Oxygen would be having positive charge and carbon would be having negative charge. Fantastic. This much clear to you? Now again resonance is possible. Yes, in the ring, negative charge means lone pair. So see, this is double bond, this is single bond, and this is lone pair. So what is resonance? Your lone pair are transferred here and your pi bond is transferred here. So see, this is as it is. I have made this as it is, this pi bond also as it is. You have double bond between this, you have negative charge here. Tell me in the chat section, is resonance further possible? Is resonance further possible? Tell me in the chat section. Yes. Again, see, here there is double bond, single bond, and negative charge means what? Lone pair. So again there is possible. Again it is possible. Just write 1, 2, 3, 1, 2, 3. Similarly, just make these structures as it is and make a double bond between 1 and 2 and take your charge on 1. This was the trick. Alright, this was the trick. Now again tell me here in this structure, is resonance possible? Come on everyone, is resonance possible in this structure? Is resonance possible in this structure? Yes. Again see, this is your double bond, this is your single bond, and this is your negative charge. Alright. So again resonance would be possible. What would be your this lone pair would come here and your pi bond would shift here. So see, what is the structure now? This these structures are as it is. Now oxygen has single bond, so there is no charge, and this is this. All right, now please observe, this is your A structure, now this is your B structure. Sorry, not AB, this structure and this structure. Observe the structure and tell me, are these same or different? Tell me, are these same or different? The structure which I have ticked, this one and this one, these are different structures. Why? Because you see the arrangement of pi bond in benzene. You have rotated the complete pi bonds. Complete pi bonds are rotated. So yes, there are A, B, C, D and E. Yes, there are 5 resonating structures. There are 5 resonating structures. Fantastic. Yes, very good Devaki, very good. There are 5 resonating structures. All right. Is this possible? Now why we are saying this as plus R? Why we are saying this as plus R? Because they are electron donating groups. If you carefully observe, this OH group is donating its lone pair. Correct? This OH group is donating its lone pair. That's why this is known as plus R. Got it? Now what are the examples of plus R? We need to identify a plus R. Identification of plus R. We need to identify those groups. Like I have given you one example, OH, right? But there are many groups which show plus R. So identification of plus R is they have lone pairs. Correct? Are you getting my point? If they have lone pair, they can donate. That means they are electron donating. That means they are plus R. Alright, let me give you examples. One example was OH, it has lone pair. Another example is OCH3, again it has lone pair. Getting my point? NH2, now nitrogen is forming 3 bonds. Number of valence electrons in nitrogen is 5. 3 bonds are used in bonding, so there must be having what? Lone pair. Correct? Similarly, your halogens, your chlorine, your fluorine, chlorine, your bromine, your iodine, all they have this lone pairs. All have these lone pairs. Alright, so these lone pairs, if they have lone pair, if they would be attached with this benzene, suppose I attach this NH2 with the benzene, so this NH2 group would show plus R. Why? Because it has lone pair. It will also donate, na? It will also donate electrons. Are you getting my point? Is this much very clear to you? So you need to identify these things. So plus R identification is with the lone pair. If it has lone pair, you can say it has plus R. Is this much clear? There is no order. Richu, there is no order. All are same. There is no order as such. All will show plus R. Got it? There is no order as such of plus R. This much clear to you all? Is this much clear? Give me a thumbs up in the chat section, everyone. Come on. Alright? Okay. Now see, there are two types of resonance. One is plus R, which I have explained you. Another is, second is minus R. I am writing it down as electron withdrawing groups. Electron withdrawing groups, minus R. Alright? Alright? Yes, we will surely check the stability order. Will surely come in further classes about the stability order. Right now I'm giving you basic concept about it. Alright? So these are minus R. Minus R is electron withdrawing group. Now electron withdrawing group, let me give you example of it. Let me first give you example of it. This is your benzene ring. This is NO2, N double bond O, and this oxygen. Tell me whether resonance possible with the NO2 group. See, you can always say in the benzene ring, double bond, single bond, double bond, single bond, there is resonance. Is resonance possible with the NO2 group? And if it is possible, what type of system is this? Come on. Thank you, Devaki. Thank you. You just need to attend classes regularly. Everything, each and everything would be cleared to you. Crystal clear. Yeah. Come on, tell me. Is resonance possible with the NO2 group? You need to identify the system. Fantastic. Great. Yes. See, here there is double bond, single bond, and double bond. Fantastic. Double, single, double bond. Yes. So see, how do we do it? This pi bond is shifted here, and this pi bond shifts on oxygen. So let me write the resonating structures. First, write down those things which you haven't touched. So you haven't touched this. Alright. So see, this pi bond is moving here. So this has double bond, nitrogen. This oxygen remains same, and this pi bond is moving on this carbon. So this is acquiring negative charge, and this carbon would acquire positive charge. Why? Because see, this pi bond is moving away from it. So when it will move away from it, it will acquire positive charge. Alright. Now again tell me, with this positive charge, is resonance possible? Come on everyone. In the chat section, is resonance possible with this positive charge? Is resonance possible? Yes. See, this is your double bond. This is your single bond, and plus charge means empty orbital, your first system. Yes, very good. Alright, so this pi bond is alright. 1 2 3 system. Okay, let's do 1 2 3 system. 1 2 3. What do? We first write all those which we are not touching in this resonating structure. This is same. Got it? Just make a pi bond. Just make a pi bond between 2 and 3 and bring your charge on 1. Is this much clear to you? Is this much clear to you? So these are electron withdrawing, means they are withdrawing electrons from benzene. Let me explain you. See, these first type of system was electron donating. So because the group was donating its electron to the benzene ring. Alright, that's why if you see, benzene ring is acquiring negative charge. See, there it is negative charge, here it is negative charge, here it is negative charge. Alright, it is donating electrons. But the second type of system, it is electron withdrawing. It is taking out electrons from benzene. That's why your benzene ring is acquiring, see, positive charge. It is acquiring positive charge. They minus R withdraws electron. All right, they decrease electron density on benzene. Correct? Why? Because benzene is acquiring positive charge. Positive charge means electron density is decreasing. Similarly, we can write plus R increases electron density on benzene. Got it? Why? Because benzene was acquiring negative charge. Is this much clear to you? Tell me in the chat section if is this much clear to all of you. Alright, now we need to identify minus R. Identification of minus R. Just like we have studied identification of plus R. What was the identification? They must be having lone pair. Now see, there is a bit of trick here. For minus R, there is a bit of trick. For identification of minus R, just please pay attention here. Your the structure of the molecule should be like this: X double bond Y or X triple bond Y, where electronegativity of Y is greater than electronegativity of X. You need to identify this with this example. Yes, Devaki. Devaki, further resonance would be possible. I am just making these three structures. Rest you know how to rest you know how to make it. All right. Yes. Further resonance would be possible. Now please see identification of minus R. Now this Y molecule should have more electronegative, should be more powerful than X. Example. First example is NO2, as I have explained. N double bond O. See, try to identify it by yourself. Come on, try to identify it by yourself. Now suppose this is your X, suppose this is your Y. Now X double bond Y, and Y electronegativity is more than X. Oxygen electronegativity is more than nitrogen. So yes, NO2 shows minus R. Is this much clear to you? Are you able to identify? Again, tell me this. Suppose CHO group. Expand this. C double bond OH. Will it show minus R? Tell me in the chat section. Will it show minus R? Come on. Tell me in the chat section. Will it show minus R or not? Suppose this is your X, this is your Y, X double bond Y, where Y electronegativity is greater than X, oxygen electronegativity is greater than carbon. Yes, it shows minus R. Fantastic, great. Okay, one more example. COOH. Expand it. C double bond OH. Will it show minus R? Will it show minus R? Tell me in the chat section. Again, this is your X, this is your Y. Alright, so Y electronegativity is greater than X. It will also show minus R. Fantastic. Great. You guys are studying really good. You guys are great students, very much able to understand everything. Alright. Now tell me CN. C triple bond N. Is this would show minus R or not? Come on. Will this CN group shows minus R or not? Everyone give me a answer in the chat section. Come on, everybody needs to be active. Yes, Arya. Yes, Richu. Great. Yes, simple trick is this is your X, this is your y, and y electronegativity is greater than x. Simple. This will also show minus r. Now you are very much um, able to identify what is plus r, what is minus r. Fantastic. Great. Great. I am pretty happy with all of you. Now tell me in the chat section, is everything resonance is still not completed? Resonance is still not completed. A small portion of resonance is remaining. You need to find aromatic, anti-aromatic and non-aromatic character. That I would be explaining you with inductive and hyperconjugation only. Alright, that would be good. So because uh, this I think this complete till now resonance is till now it is clear to all of you. Now see, I'm again quickly in 2 minutes we will again see all the slides, all right, just please wait. All right, one shot video. So, okay, what is basically resonance? Resonance is shifting of pi electrons and pi and lone pairs. All right, resonating structures are hypothetical. Resonating structure, the resonance hybrid is real. All right, then we have seen some conditions that they should be planar, position should remain fixed, pi bond and lone pair are interconvertible. All right, then we have studied types of system. Types of system types of system means you need to identify resonance. No, Richu, we will be doing it then in the next class. That would be better. All right, because we cannot do it fast. I need to explain it very deeply. All right. Yes. Types of system. So see, first was double bond, single bond, empty orbital. Empty orbital means positive charge. All right. The other type of system was a double bond, single bond, lone pair, or double bond, single bond, odd electron. Lone pair means negative charge. Then the third and last type of our system was Richu, we are having regular classes at 11 a.m. All right. So tomorrow there would be no class. It is Sunday. On Monday we will be having physical chemistry, and on Tuesday we will be having organic chemistry. All right. So every day we have classes at 11 a.m. So yes, the third type of system was double, single, double, double, single, double, your third type of system. All right. Then we have seen the stabilities. Resonance hybrid is the most stable, but we need to identify different stabilities of all the resonating structures. So first rule was more the number of pi bonds, more is the stability. Second structure was neutral structures are more stable. Neutral structures are more stable. Let me just finish this, then I will take all your doubt sessions. Just let me finish this. Then I have just told you opposite charges should be close. Then we have explained types of resonance. Plus R means electron donating, increase electron density on benzene, and minus R means electron withdrawing, they decrease electron density on benzene. And I have told you identification of both. All right, now you guys can ask me any question you have. Let me see, there are some new students. Let me explain them uh, how we are conducting classes. Please wait. Yes, how we are conducting classes, we are having at 11 a.m. we are having a regular class. All right, daily we are having class. One day we will study physical chemistry, and the other day we will study organic chemistry. Yes, organic chemistry we will continue from here only. Arya, yes, organic chemistry will be continued from here only. Richu, physical chemistry we are studying mole concept right now, and in organic chemistry we are studying GOC, general organic chemistry. Is this much clear to you? Do you have any doubt? Tell me in the chat section. Anyone having any doubt can ask me. Anyone having any doubt can surely ask me. Come on. Alright, so subscribe to this channel, hit the bell icon, and also like this video. Everyone like this video. This is very needed. And whenever you are buying the subscription, just apply this code Nitesh YT. You will help me a bit, and just apply the code. you will get 10% off. Nitesh YT. Nitesh YT. If you have any doubt, you can ask me. To find stability, examples for rule 1. Yes, Devaki, rule 1 was pi bonds. If it has more pi bond, more the stability. Rule 2 was neutral and charge. Alright, we have taken examples also. Yes, Richu, you can surely get crystal clear concept. As I have explained you today, I'll be explaining you each and everything. Come on. Any more questions you have? You can surely ask me in the chat section. Come on everyone, like this video and ask me your doubts. Which example, Devaki? Okay, I'll explain you for rule 1 and rule 2. Okay, wait, I will explain you. Wait. So see, this was your example. Alright, so see, first rule, this has one pi bond. This has one pi bond. Correct? This is your pi bond. This has 0 pi bond. So more the number of pi bond, more is the stability. So A is more stable than B. Alright. Okay. Now for the second example, now if you see this also has one pi bond, this also has one pi bond. So on the basis of pi bond, you are not able to differentiate. Next rule was neutral structures are more stable. A is your neutral, B is charge. Why it is charge? It has negative and it has positive charge. So A is more stable than B. Alright, so these two are the examples. Now is it clear, Devaki? Yes, Richu, we would be taking ionic equilibrium also and mole concept. We are studying very much in detail. You just need to attend the classes at 11 a.m. regularly. All right. Great. Any more questions you want to ask? Please ask all your questions. Please ask all your okay, all crystal clear. Great, Devaki. Fantastic. Fantastic. Okay. Then tomorrow we won't be having class. Tomorrow is Sunday. You can rest. You can watch videos, previous videos if you haven't watched it, and you try to make notes also. And then we will meet on Monday. We will meet on Monday. All right. Because every structure, Richu, every structure in this universe wants to be neutral. Charged species means reactivity is more. That's why neutral structures are more stable. No. Neutral structures are more stable because every molecule everywhere wants to be in their neutral state. No, I got your point, Richu, but neutral structures are always better. Why? Because charged structures are reactive. They are reactive. All right. Any more questions? Any more questions you have? Okay, so we will meet in the next class. Thank you very much for joining. Thank you very much. Take care. Bye bye. And if you are again, I'm telling you, if you're buying the subscription plan, just apply this code Nitesh YT. You will help me a lot. 10% off you will also get, and you will help me also. All right. So thank you very much. Bye bye. Take care. I will see you on Monday.